Hello everyone. Today we are going to calculate the settlement of a footing. And in shallow foundation, we have already seen how to calculate the bearing capacity by using Tarjagi's bearing capacity theory or IS code method. Today we will try to find out the settlement of this footing. So the example is a footing of size 2 meter by 2 meter. That means it is a square footing is embedded in cohesive bed as shown in figure like this. So this is uniform clay. So this is uniform clay, normally consolidated clay. So it is NC clay having gamma saturated equal to 18 kilonewton per cubic meter, and the unit weight of water is assumed to be 10 kilonewton per cubic meter. And above this, above the base of the footing is going to be sand. And the water table is going to touch with the groundwater table. And the intensity of the loading at the base of the footing is 200 kilopascal. So in this footing, the intensity of loading is 200 kilopascal. And this sandy deposit above the base of the footing has got gamma T equal to 20 kilonewton per cubic meter. The depth of the footing is given to you as 2 meter, and the width of the footing is going to be 2 meter. And calculate the settlement of the footing. So as you see, it is a normally consolidated clay, and therefore the settlement will be settlement of the footing will be consolidation settlement. So this is going to be consolidation settlement. SC. So we need to calculate the consolidation settlement. So if you need to calculate the other properties of normally consolidated clay is given to you as liquid limit is given, so 40%. And the natural moisture content is fully saturated, is also known to you, it is 30%. So the value of G, that is a specific gravity, is 2.7. So these are the informations that's given from the soil test. We know it. And we need to calculate the consolidation settlement. Now, because the load is being transferred through the footing over the normally consolidated clay, this consolidation settlement SC will be given by Cc divided by 1 plus E naught into H into log of sigma naught prime plus delta sigma prime divided by sigma naught prime to the base 10. How will you find out the value of compression index Cc? Cc is called compression index. This is one of the parameter which you get it from consolidation test, or there is a empirical relationship widely used. The Cc can be calculated by knowing the final void ratio after application of the load minus the original void ratio without application of the load divided by log of sigma naught prime plus delta sigma prime divided by sigma naught prime to the base 10. This you can find it out by performing consolidation test. But because you don't have these values known to you, therefore, what you can do, that you can use empirical relationship. So what is the empirical relationship? The empirical relationship formula for finding out Cc is given as 0.009 liquid limit minus 10. So liquid limit is 40 minus 10, this becomes 30 into 0.009, this becomes 0.27. So Cc we know. Now how to find out E naught? Because here you know gamma saturated is known to you. So you can find out the dry unit weight, gamma D. And gamma D equal to G gamma W upon 1 plus E naught. From three-phase system, you know the interrelationship. G is 2.7, gamma W has been assumed as 10 kilonewton per cubic meter. Gamma D you can calculate because you know gamma saturated. So gamma D will be gamma saturated, that is 18, divided by 1 plus moisture content. And the moisture content is 0.3, 30%. So 1 plus 0.3, this becomes 1.3, equal to 2.7 into 10, 1 plus E naught. Therefore, E naught is going to be 27 into 1.3 divided by 18 minus 1. And therefore, if you calculate, you will be able to get it. So, if you calculate, the value will be 27 into 1.3 divided by 18 equal to 0.95. So 27 into 1.3 divided by 18 minus 1 gives you 0.95. So I've got now E naught also. Now what is H? Is the below the loading, what is the depth of influence, that is H, and H will be the depth in which the load will be felt, this intensity of loading that will be felt in a zone, and that zone where the 0.1% of Q, 10% of Q is going to be felt. So it is going to be zero point 0.1 times of Q. That pressure bulb is going to be in a up to particular depth, and that depth from shear criteria is taken as capital H, depth of influence. It is going to be 2 times the width of the footing. So this is going to be 4 meter. So I know the value of H. Now, as per IS 8009, we should divide this whole depth into 3 parts. So if you divide it into 3 parts, then you will be able to get the value. So now the value of E naught we have been able to calculate as 0.95, and uh, and the H below the base of the footing is going to be 4 meter. Therefore, divide into 3 parts. Therefore, H1 equal to H2 can be kept as 1 meter each, and H3 can be taken as 2 meters. So total 2 plus 2, H equal to H1 plus H2 plus H3 equal to 4 meter. Now, when you divide this H into 3 layers, 3 parts, let's say this is the first part. So this is layer 1. This is going to be another layer 2, and this is going to be third layer. So 3 layers. This is going to be 1 meter, H1, 1 meter. This is going to be H2, 1 meter, and H3 equal to 2 meter. So all the 3 layers, so total H equal to 4 meter. Now at the center, midpoint of each layer, you should be in a position, let's say the midpoint of each layer, we can mark it. For layer 1, the midpoint is A. For layer 2, the midpoint is B. And for layer 3, the midpoint is C. And therefore, I should be in a position to calculate this sigma naught prime. What is sigma naught prime? The sigma for, let's say, for layer 1, at the midpoint of layer 1, that is at A, calculate sigma naught prime, this one. So sigma naught prime is called effective overburden pressure, which will be equal to the unit weight multiplied by Z from ground level, depth of that point from the ground level. So for layer 1, the value of sigma naught prime will be, now above this you can see the gamma T is 20 kilonewton per cubic meter. So the effective will be 20 into 2 for sandy part, plus below the base of the footing it is underwater. So it is going to be gamma prime, that is 18 minus 10 unit weight of water multiplied by 0.5 at A. So sigma naught prime at the midpoint, that is at A, have been calculated like this. So this becomes 40 and this becomes 4. So 44. 22 is 40 and half of 8 becomes 4. So this becomes 44 kilopascal. Right? Now what is next term? There is delta sigma prime. What is delta sigma prime? After applying this external loading through the footing, post construction, what is the intensity of the loading? That intensity of the loading is 200 kilopascal. This is applied post construction. Before construction, the effective overburden pressure is 44 kilopascal. But post construction, when the live load is going to be applied, this intensity of loading is known to you. So at the midpoint, what is the increase? Now load is going to spread at 2 vertical and 1 horizontal. So load will be spreading at 2 vertical and 1 horizontal. So at the midpoint, if you go to the midpoint, what is the change in size? This is 2 meter, B equal to 2 meter. So from this point to this point, it is 2 meter, and this height is going to be 0.5 meter. So 0.5 by 2 and 0.5 by, because 2 vertical, 1 horizontal. So it becomes 0.5 by 2 and 0.5 by 2 this side. So at 0.5 meter from the base of the footing, this dimension B is going to increase by 0.5 meter. So the value of delta sigma prime, so calculate delta sigma prime at point A. So the passing from the point A. So delta sigma prime for layer 1 can be computed now. So delta sigma prime for layer 1 will be, what is the intensity of loading? It is 200 multiplied by B, which is 2 meter, multiplied by L, which is 2 meter, divided by B plus delta B, because load is now spreading at 2 vertical to 1 horizontal. So what is the increase in B whole square? Because it is a square footing. So in a square footing, had it been a rectangular footing, then it would have been L plus delta L. But it is a square footing, so whole square. So this is going to be 800, 200 into 4, 800, and B is 2 meter, plus delta B is 0.5. So 0.5 whole square. So if you calculate it for layer 1, you will be able to get the value of delta sigma prime, and delta sigma prime can be computed now. So if you calculate it, the value of delta sigma prime is going to be 800 divided by 2.5 square equal to 128. So the value is 128 kilopascal. So 128 kilopascal. So I have got this also. I have got this also. I know H1. Therefore, you can compute the consolidation settlement for the layer 1. So if you calculate substitute the values and calculate, then the values will be like this. For layer 1, therefore, for layer 1, the consolidation settlement SC1 is going to be CC, which was 0.27, 0.27 divided by 1.95. H1 is 1 meter into log sigma naught prime is 44 plus delta sigma prime is 128 divided by sigma naught prime is 44 to the base 10. So if we calculate, we will be getting the value of SC1. So let us calculate now. So if you want to calculate this, is going to be log log of 44 plus 128 divided by 44, bracket closed. 44 plus 128 divided by 44 multiplied by 0.27 and divided by 1.95. So this is going to give you 0.0819 meter. So SC1 equal to 0.0819 meter. That means it is going to be 81.9 millimeter. Right? So it is going to be 81.9. Similarly, for layer 2, this is the second layer. Now what is H2? It is 1 meter. So now you can calculate SC2. It will be 0.27 cc divided by 1 plus E naught will be 1.95. H2 will be 1 meter and log of sigma naught prime at this point at B. So calculate now for layer 2. sigma naught prime at point P, midpoint. At midpoint, this is going to be over 1 meter plus 0.5 meter. So 1.5 plus 2, that is 3.5. So this is going to be 3 point. So first 2 meter, 20 into 2 plus 1.5 meter, remaining 1 meter plus 0.5 meter. The effective unit weight is going to be 18 minus 10, right? As we have calculated here. Similarly, it will become 40. This becomes 40. This becomes 1.5 times of 8, that is 12. So this becomes 52. So this becomes 52 here. Now, delta sigma prime, the increase in pressure at this point will be now up to midpoint. This is going to be 2 and this is going to be 1.5. So it is going to be 200 into 2 into 2, that is 800, divided by 2 plus 1.5, because point B is at a depth of 1.5 whole square. So if you calculate this, so we can calculate this. So it becomes 800 divided by 3.5 square. That is 65.3 kilopascal. So 65.3, sigma naught prime plus delta sigma prime divided by sigma naught prime. Here the sigma naught prime and delta sigma prime was 128, 800, that we can check it, 800 divided by 2.5 square, 128. Okay, this is correct. This for layer 1 it was 128, which has come down to this. So let's calculate now. So log of 52 plus 65.3 bracket closed divided by 52 multiplied by 0.27 divided by 1.95 gives me SC2 equal to this value is 0.0489. So this is going to be 48.9 millimeter. So SC1, you got the answer as SC1 in the previous case, which was 81.9 millimeter, and SC2 you calculated just now as 48.9 millimeter. Now the third layer is going to be of 2 meter. So now SC3 you need to calculate. So if you calculate SC3, so let us calculate now SC3. So if you calculate SC3, SC3 will be equal to SC3 will be equal to Cc divided by 1 plus E naught into H3. Now H3 is 2 meter. So here it will be 2 meter into log of sigma naught prime. So what is sigma naught prime at point C? So for layer 3, so this is layer 3. We are calculating now SC3 equal to 2 meter and sigma naught prime, the effective, will be 20 into 2, that is 40, plus this is 1, 2, and this is 1, 3. So 3 meter multiplied by 18 minus 10, that is 8. So this becomes 24 and this becomes 40. So this becomes 64. So this is 64 plus. Now delta sigma prime will be 800 divided by 2 plus, at what depth you are going to have? 1 meter plus 1 meter, 2 meter plus 1 meter, 3 meters. So plus 3 whole square. So this becomes equal to 800. Let's calculate this. 800 divided by 25. 32. 32. So this becomes 32 divided by 64 to the base 10. So you see how you have been able to calculate and see the reduction in the value of delta sigma 3 as you go deeper. It becomes substantially less. In the first layer, it was very high, 128. It has come down to mere 32. So that's why you have to go 2 times B, and that has to be divided into 3 layers. So let's now calculate this. So if we calculate this, this is going to be log of 64 plus 32 bracket closed divided by 64 bracket closed multiplied by 2 into 0.27 divided by 1.95. This gives you equal to 0.0487 meter. That means this is equal to 48.7 millimeter. So this becomes SC3 equal to 48.7 millimeter. Therefore, the value of final answer you have got now, that the calculate the consolidation settlement. Therefore, the consolidation settlement of this footing SC will be equal to SC1 plus SC2 plus SC3. That means it is going to be 81.9 plus 48.9 plus 48.7 millimeter. So if you add up, you can get the value as 81.9 plus 48.9 plus 48.7 equal to 179.5. 179.5. So this is how you can calculate the settlement and this is given in IS 8009 part 1. Thank you very much.